What's up, y'all? Today is February 6th. My brother got me a issue of Scientific American. Not issue, I should say, subscription for a year. This is one issue of it. It says here, search for Planet X. Is it hidden in the solar system's outer reaches? I'm going to go ahead and read on page 33. See, the guy who wrote this is Michael D. Lemonick is the author of Mirror Earth, A Search for Our Planet's Twin, by Walter Books 2012. For 21 years, he was a science writer for Time magazine. He is now Scientific American's opinion editor. Alright, here we go. Page 33, it says, On the Trail of Hidden Worlds, and I'll give you a little overview of what I think is going on here. The first search for a hidden planet encircling the Sun came in the early 1800s, when scientists became increasingly convinced that Uranus, discovered accidentally in 1781 by the musician-turned-astronomer William Herschel, I talk about him in another talk, was not orbiting quite as Newton's law of gravity said it should. Several scientists posited that the gravity of a large undiscovered planet was to blame, and in 1846 German astronomer John Gale spotted the gas giant Neptune, basically where his French colleague Urbain Le Verrier had calculated it should be. There is good evidence that Galileo had actually seen Neptune as early as 1612 with his small crude telescope, but assumed it was a star. In the early 1900s, Boston aristocrat Percival Lowell began a search for another hidden planet based at his own personal observatory in Flagstaff, Arizona. This time, the evidence came in the form of anomalies in the orbits of both Uranus and Neptune, pointing to the existence of yet another unseen giant planet. Early in 1930, a young assistant at Lowell Observatory named Clyde Tombaugh found a planet more or less where the calculation said it should be, a replay of the discovery of Neptune. Quote, the sphere, possibly larger than Jupiter and 4 billion miles away, meets predictions, end quote, the New York Times announced on March 14, 1930. It did not, though. Within a few decades, it became clear that Pluto is far from Jupiter's size and is actually smaller than Earth's moon. Its meager gravity could not possibly explain anomalies in the orbits of Neptune and Uranus, which turned out to be just as well because those anomalies faded away on further inspection. In that sense, Pluto was a false alarm. In the big picture, however, its discovery was extraordinarily important. By 1980s, planetary scientists had begun to suspect Pluto was not a puny planet orbiting all alone in the solar system's frozen outskirts, but simply the brightest member of a vast, richly populated region known as the Kuiper Belt. In 1992, the first KBO, which is Kuiper Belt object, besides Pluto that is, was spotted with a telescope in Hawaii, and since then observers have tallied another 1,500 or so. It's a lot of objects out there. The 2005 discovery of Eris, which rivals Pluto in size and significantly outweighs it, threatened to open a floodgate that could have added several more planets to the existing roster of 9. The specter prompted the International Astronomical Union to demote Pluto from planet to dwarf planet in 2006. My thoughts on this: gravitational anomaly being caused by something outside of itself. Okay, so the way I look at it is this. If you observe something in outer space and you say, well, there's a gravitational anomaly, it's not acting as Newton's law of gravity had predicted. They had basically two options. They say, well, maybe Newton's law of gravity, or no, they should have said, well, they did say that there's something that's causing this because of Newton's law of gravity, because Newton's law of gravity cannot be correct. There's something causing these anomalies. But then when they found that Pluto couldn't explain the gravitational anomalies, they just left it alone, and then they kept Newton's law of gravity. Instead, what they should have done and said, wait a second, Newton's law of gravity is incomplete. Oops. But then they go off on the general relativity stuff, and it's like, what? How is space and time bending explain anything rationally? So what we have here is a sort of cliff, if you will, of understanding. You have a bunch of people that believe a certain thing, and they're just stuck. They're standing on the edge of a cliff. It's like that part in the Indiana Jones movie where he has to cross that chasm, and it's called the leap of faith, if you will. And what he does is he takes a bunch of little pebbles and he throws it onto the bridge, because the bridge is completely camouflaged and you can't see it. So that's how you get across. But the scientists these days, they don't want to throw those pebbles onto the bridge to see that there's actually something there, so they can move past Newton's law of gravity. And I think those pebbles really amount to trying to explain things in terms of electromagnetic interactions, as well as different types of things that could be going on, such as maybe the sun is losing mass. Think about it. If you have something that's causing a slight perturbation or anomaly inside of an object that's so many miles away, maybe it's not that there's interaction at that point, but that whatever is keeping it in its orbit is changing, is losing mass. To think it's so far away that even a little bit of mass lost from the sun would have enormous consequences to objects that are really, really, really far away. But obviously, throwing the pebbles onto the bridge to see that there's actually a bridge there isn't in the astronomer's best interest. They don't want to stir things up. They don't want to mix things up, and they don't want to look outside of their in-group's mentality, because it's scary to be on your own. All right, well, there you go. I suggest reading the article. I'm sure you could probably find it at Barnes & Noble or Books A Million or something. It has these cool little graphs here showing where all the orbits are. But pretty interesting stuff here. As well, when you read articles like this, try to examine what's being written. Try to look for all the assumptions. Try to look for all the things that might be incorrect. Because these people, you got to realize that science isn't something that's set in stone. It's constantly evolving and changing. So try to see where science will evolve and change in regards to this kind of stuff, and you can probably predict what's going to happen next inside of those communities. Alright, later.